Hello and welcome. My name is Carol Abbey, and this is the thesis defense presentation for my research from September 2022 titled A Conceptual Model of a Stigmergic Information System Network for Social Sustainability. This defense was presented to Business Science Institute, iaeLyon, and the Skema Business School. I will cover an introduction, the literature, methodology, data collection, data analysis, results, and conclusion. There is a broad and growing interest in how business activities benefit or harm society. Businesses are calling for shared value and alignment with their communities. Social organizations need to demonstrate their social impacts to funders and partners. Governments are seeking integrated approaches with business. Investors and funders want to direct their money to the most effective projects, and policymakers need to inform their constituents of their spending decisions. And we all know that what gets measured gets managed. So, what is currently being measured to clarify the benefit or harm of business activities? There are hundreds of competing assessments, metrics, and tools for measuring social value. And often these methods are tweaked and tailored to an individual organization situation. Yet, there's also a demand for market comparability of this data. And technology is promising efficiency improvements to collect and assess the data systematically. And with that, there is a call to academia to develop a logical structure to harmonize social sustainability data, considering the various stakeholders, which can be applied across complex systems operating at multiple scales. This creates new challenges because society is a dynamic system that is constantly changing, but computer systems and algorithms require a certain level of consistency. Machines need rules and information structures. And there are broad implications with such a system, so we need a guide. We need a guide, an initial model that maps the foundational logic before someone starts programming technologies to think about topics that are as important to our daily lives as social sustainability. This led to the research question: is it possible to design such a conceptual model representing social sustainability interconnections for an information system network? And with that, I want to clarify a few working definitions. This research defines sustainability as the capacity to endure, and social sustainability as the capacity of human society to endure. And social sustainability interconnections refer to the formal and informal processes, systems, and relationships for stable communities today and for future generations. Next, we'll move into the literature and the theoretical background. There are four theoretical pillars which emerge during this inductive research process: social sustainability, systems thinking, systems dynamics, and stigmergic systems. Social sustainability is the purpose and the overarching boundary condition of this information system network. By social sustainability, we're referring to the United Nations Sustainable Development Goals. We're looking at Raworth's social and planetary boundaries, and we're looking into the macro scale technical initiatives for social sustainability. And as we're talking about systems thinking, we're looking at the analytic skills to understand these social systems, to consider predictive behaviors, to automate workflows, to build models, to design solutions, and to devise modifications in order to influence desired effects for complex social change. System dynamics are the analytical capabilities to get to the root of complex social activities and societal activities, to introduce predictive capabilities using stocks, flows, internal feedback loops, table functions, and time delays. And a word that may be less familiar to many of you is Stigmergic systems. Stigmergic systems are scale-free architectures for self-organization processes. Stigmergic systems refer to framing of groups of software services based on role and field activities. And a Stigmergic platform acts as a facilitator for self-organization processes with actor base and software ecosystem architecture. Methodology. I'd like to be clear that this research methodology is not a traditional research methodology, and therefore, perhaps because it is less well known, I'm going to go into more detail here. The inductive top-down theory building approach was developed by Shepard and Sutcliffe in 2011. This methodology was introduced to me by the Business Science Institute in the core coursework. It was selected because it is appropriate for understanding and resolving paradoxes. It is effective at enhancing discovery across paradigms, and it is suitable when existing literature is vast and dynamic. The inductive top-down theorizing approach was developed from coherence theory and holds pragmatist traditions. It is generally an inductive approach because it draws from a wide range of information, resulting in a generalized theory. Now, the term top down in this case refers to the existing literature, which is the data. And it applies abduction to address the real world problems that the literature does not answer well. So, when you put it all together, deduction and abduction detect the paradox from within the existing knowledge, the existing literature. Simultaneously, inductive and abductive reasoning develop a new theoretical model. Let's look at how that actually plays out. This is a diagram of the inductive top-down theorizing approach. The theorizing starts with the literature, focusing attention with data drawn out of the social value and social impact assessment literature. Patterns and relationships begin to take the form of a sensory representation, which is then contextualized through constant comparison by applying thought trials through metaphor, which is further refined based upon its potential contribution to identify practical components which are put together in a conceptual representation. Now, this process is guided by the theorist's prior knowledge, and it is constrained and restricted by the scholarly context. And this process repeats with several iterations until saturation and refinement of a new theory is achieved. This research documents this very iterative process into 3 building blocks so that it can be palatable to the reader. Building block 1 is a landscape theory review. Building block 2 is thought trials through metaphor. Building block 3 consolidates the findings into diagrams with a narrative text for conceptual representation. Each building block has an output that feeds into the next. Network relationships and societal requirements feed into the contextualization and pragmatic considerations, which feeds into the conceptual model building. Next, we'll go into the data collection, including the literature selection and protocol. Again, remember the literature is the data. So this literature included theories, metrics, assessments, and tools that document the measuring of social value for business and or societal institutions. Business included private and public sector businesses. Societal institutions included national governments, as well as macro-scaled organizations measuring social value. Only research that took social value, a view of social value from a generalizable national, country, or global societal perspective was included. Data collection protocol included training, practical screening, search, data extraction, and synthesis approach following the guidelines by Kitchenham and Charters. The search took place across 12 databases. 73 research papers were screened. 15 research papers were selected for extraction, and manual collection was organized into an Excel table in preparation for data analysis. There are three building blocks for the data analysis. Building block one, the landscape theory review. The data analysis explored social value or social impact, the terminological ambiguity, investigating the definitions, the jungle of assessment methods for social value and social impact, considering assessment focus and characteristics of measurement methods, then looked at perspective, investigating the reasons stakeholders measure and challenges they experience. The output of building block one included definition harmonization and unification of Tier 1 social value and social impact terminology, stakeholder relationship mapping, and 7 requirements for an information system network for social sustainability. Building block 2, thought trials through metaphor. The metaphor of flux and transformation includes the following 4 processes of logic and change: relationships between systems and their environments, chaos and complexity theory, cybernetics, and change as a tension between opposites. A metaphor provides a recognizable bridge of analogy to direct attention to the subtle parallels while retaining an openness for a new and unique theory to emerge. The outputs of building block 2 included contextualization for pragmatic considerations. We envisioned the new phenomenon of scale-free distributed technologies as a solution, with consideration to the dilemma of dynamic societal complexity, taking the perspective that societies operate within a paradox of eternal change. Building block 3. Here's where the conceptual model begins to take form. There are 3 scales of participation. At the macro society scale, we have control services, rules, and governance. At the meso group scale, we have organization systems for coordination and exchange. At the micro individual scale, we have actions and value quantification. Social sustainability boundary conditions are a minimum or maximum condition or constraint to be set within an equation or an algorithm to value a problem or a solution. These 3 scales each operate within different boundary conditions. At the macro scale, the boundary conditions for social stability include the ecological ceiling constraints and minimum social foundation conditions. At the meso scale, the boundary conditions include shared value, meaning that an organization creates both benefit for the organization as well as a benefit for society. And at the micro scale, the boundary conditions included existential goal values. Data and information are directed and flow based upon the logic of relationship and impact between one scalar element and another. Requests from individuals are directed to the mesoscale for organization and resource exchange, and societal priorities and problems are aggregated and directed to the macro scale. Organizations benefit with information for strategy, monitoring, and reporting social sustainability data. Society at the macro scale gets the data to support decision making and to ensure societal stability and endurance. All parties benefit through a network of synergized demand, capacity, and coordination activities to address social requests and problems by design. System dynamics considers technical structures for both operations and analytics. Automation of microtasks of data gathering offer operational efficiency and scalability. Adding a layer of analytics introduces predictive capabilities for policy design and feedback loops to monitor and continuously adapt to improve societal outcomes. Stigmergic information systems utilize a flexible data mesh topology across an ecosystem, and it leverages role-based operational and analytic automation for cyber-physical coordination. Basic tasks are directed to individual contributors by programming initiating events for Stigmergic self-organization, resulting in a Stigmergic information system network for social sustainability. Putting all the previous components together, this model conceptualizes a framework of patterns that bring together and unifies different sets of social value and social impact indicators for systemic alignment with social sustainability in a manner in which machines can be instructed or programmed. The model separates a prototyping area from model building, testing, and machine learning training. This is a standard within software development. Information exchange takes place across all scales within the Stigmergic information ecosystem. Analytics are essential to the model. Integrated dynamic feedback loops offer predictive, corrective, and retrospective analytics to support decision making at various stages of a change activity, starting with screening, then monitoring, then reporting, and evaluating both short and long term impacts. Control loops are applied against control module parameters, and boundary conditions act as a systemic thermostat for stability to reduce perception bias and to monitor for exploitive effects. This offers expansive learning cycles for comparison against initial expectations, and predictive model reviews over time introduce computation as cognition for continual improvement of predictive capabilities. This conceptual model provides a guide for stakeholders to discuss and agree on the logical structure to harmonize social sustainability datasets. It includes consideration for the technical big picture challenges. It offers the consistency required for operating systems. It satisfies the requirement of multiple scales within an environment that is constantly changing. And if developed, it would provide business with access to social sustainability data for decision making with common terminology and market comparability. Conclusion, contribution, and further studies. The research has achieved its aim. The model addresses the systemic interest in the social benefit and social harm of business activities to offer data sharing, predictive analysis, monitoring, and reporting with integrated approaches. Further, it goes one step farther and it integrates the individual stakeholders for systemic synergy. As a theoretical contribution, this research offers a unifying perspective on social value and social impact assessment, a new contextualization of applying social value within scale-free distributed information systems, and provides example of the ITD-TA, inductive top-down theorizing approach methodology as a scientific approach for theory building that can be broadly unified across specialist domains. And as a managerial contribution, a future implemented model would offer business intelligence for profitable shared value strategies for competitive advantage. In conclusion, this research is only an early step, and further studies, of course, are required to review and refine this foundational model. Thank you very much for your time, and next we will go into questions.